Ooh, let's do some algebra review. Solve 4k plus 7 parentheses, negative 4 minus 2k, NBA video game, equals negative 2 parentheses, k minus 2. Well, whenever we have parentheses on each side of the equation, we should probably distribute right off the bat. So let's do that. 4k is not affected. 7 times negative 4 is negative 28. 7 times negative 2k is negative 14k. That's going to equal, distribute again, negative 2 times k is negative 2k. That's a lousy basketball game. Joke. It's a great basketball game. Negative 2 times negative 2 is positive 4. All right. After we distribute, we should probably try to combine like terms on either side. So I have 4k over here. I have minus 14k, and that gives me negative 10k. Nothing happens with negative 28. Nothing happens with negative 2k, and nothing happens with 4. I have k on both sides of the equal sign. I have a negative 10k over here and a negative 2k over there. It doesn't really matter which one I get rid of, but I always like my k ending up on the left. So let's do the opposite of this guy and add 2k to both sides like so. Negative 10k plus 2k is negative 8k. Drop down the minus 28. Drop down the equals, drop down the positive 4. Now it's a two-step equation. Okay, in order to get k all by itself, negative 8 is attached, but the first thing we want to do is do the opposite of negative 28 and add 28 to both sides, like that. That gets us negative 8k equals 32. One more step. In order to get k all by itself, we do the opposite, well, not the opposite, we do the inverse of negative 8, which is divide negative 8, and k is going to equal negative 4. So why are we starting a geometry series by doing algebra? You are going to see a lot of algebra, specifically numbers and variables on both sides of an equal sign. So if you thought algebra was going to go away for geometry, no. Like and subscribe. All right, I have to simplify 3 times the square root of 405. Ladies and gentlemen, I'm going to use the Nick Parrish method of simplifying square roots. Step number 1, take your number inside the square root and make a factor tree out of it. So 405, I can divide that by 5, and that gets me 81, I think. Circle any prime number. What two numbers multiply out to 81? 9 and 9. Can you circle either of those? Nope, because they're not prime. But I'm going to be able to circle a lot of these. 9 is 3 and 3, circle, circle. 9 is also 3 and 3, circle, circle. So the prime factorization of 405 is 5 times 3 times 3 times 3 times 3, but not in that order. Let 3 still hang out on the outside there. Let's write these in order. 3 times 3 times 3 times 3 times 5. What you do now is, since this is a square root, we're going to circle sets of identical pairs, like this group of 3s and this group of 3s. Don't worry about that 5. It doesn't have a friend. Kind of like me in high school. Hee hee, full of jokes. Bring out one 3. Bring out another 3. And whenever we bring out more than one thing, we're going to end up multiplying. So 3 times 3 times the 3 that's already out there, square root. You're now gone, 5 is left over. So when I put all of this together, 3 times 3 times 3 is 9 times 3, which is 27. What's left over? Root 5. And that's my guy. So step 1, make a factor tree. Step 2, list it out in order. Step 3, circle groups of pairs. Step 4, pull out one of them. Step 5, multiply. The Nick Parrish method of simplifying square roots. Patent pending. Ooh, let's simplify that root minus that root minus that root. Well, you treat square roots as if there were variables. And if they were the same variable, then you would combine like terms and that would be easy. Well, none of these are the same. So you might be thinking, oh, great, we can't combine like terms. We're done. Wrong. You can combine these. We just have to simplify all three of these square roots. So in a previous video, I did the Nick Parrish method of simplifying square roots where I took all three of these and made a factor tree for them. I'm not going to do that much. I'm just going to use a little bit of common sense. So let's draw this out in black. 12 can be written as 3 times 4, which is 2 times 2 times 3. And then we have minus 2. 27 can be written out as 3 times 9 or 3 times 3 times 3, prime factorization. Again, if you need to make a factor tree, go right ahead. 45 is 9 times 5, which is 3 times 3 times 5. Now that we have the prime factorization written out, circle pairs and bring one of them out. Circle pairs and bring one of them out. Circle pairs and bring one of them out. So I have negative 3 times 2, and what's left over is regular 3, minus 2. I brought out a 3, so times 3, and what's left over is the square root of 3, minus 2, bring out a 3. What's left over is the square root of 5. So negative 3 times 2 is negative 6, negative 6 root 3. Negative 2 times 3 is negative 6 root 3. Negative 2 root 3 is negative 6. Negative 6, root 5. So now what I have to do is combine things that have the same exact square root. Negative 6 root 3 is literally the exact same thing as negative 6 root 3. So if I take away 6 root 3's and I take away 6 more root 3's, I'm taking away 12 root 3's. Okay, negative 6 minus 6 is negative 12. Root 3 comes along for a ride. Well, what about this guy? This guy wants a ride too. Can I join in? No, because you're different. And that's how we roll in math. We segregate and we don't care about others. It's really a terrible thing. But since these guys aren't the same, we can't combine them. So that's my answer. I'm done. Simplify the square root of 15 times parentheses root 3 plus root 10 close parentheses. Well, common sense tells us that we should do good old distributive property. So root 15 times root 15. Remember, when you multiply two square roots, you're allowed to multiply them within one square root. So what that means over here is square root of 15 times the square root of 3 is the same thing as the square root of 15 times 3, which is 45. Distribute again, the square root of 15 times 10 is the square root of 150. Now, before you circle that and call that a day, we're probably not done. Well, we're definitely not done. These actually might be able to combine, maybe, maybe not. I don't think so, but it's possible. And what we need to do is we need to take these aside and simplify these and see if they end up being the same square root. If they're not, then, we just have a more simplified version. So if I wanted to take 45 and make a factor tree out of that, that would be 9 and 5, 3 and 3. And so using the Nick Parrish method of simplifying square roots, this ends up being 3 times 3 times 5. Doing the same thing with 150. 150 is 10 and 15. Nothing happens there. 10 is 2 and 5. Circle them both. 15 is 3 and 5. Circle them both. And plus 150 within a square root is going to be 2355. 2 times 3 times 5 times 5. Now the next step is for each one individually, we circle groups and bring it out. So I circle a 3, bring out one of them, and what I have left over is the square root of 5. I circle 5s, bring out one of them, so plus 5, and what I have left over is 2 times 3, which is 6. So although I wasn't able to combine these, and I kind of knew that would happen, I still did my multiplication, and I still simplified as best as I could. Okay, so that's multiplying square roots, baby. Simplify the square root of 15 over the square root of 6. Two things happen here. Thing number one is if I give you something like the square root of A over the square root of B, I'm allowed to write that as the square root, one big square root of A over B. I'm allowed to do that. Why am I going to do that? Because I can write this out as the square root of 15 over 6. And I know that 15 over 6 simplifies to 5 over 2. I can divide the top and the bottom by 3. Great. Does that mean I'm done? No. Let's write it back to the way it kind of once was, where we have a square root over a square root. There's some stupid math rule that I still don't understand why, even though I've been teaching math forever, that says you're not allowed to have a square root on the bottom. You can't do it. So what we are going to do is a process called rationalizing the denominator. In order to make that square root go away, what we can do is multiply the bottom by the same exact thing. If I have a square root of 2 and I multiply it to the square root of 2, the square root of 2 times itself is the square root of 4, which is 2. However, we know that when we deal with fractions, we can't just multiply it by a number. We have to multiply it by a number that equals 1. So I'm going to multiply the top and the bottom by the square root of 2. That makes this root 5 times root 2, which is the square root of 10, over, again, I'm going to explain it, and I'm going to show you what I did, the square root of 2 squared. Okay, root 2 times root 2 is root 2 squared. Now a root 2 squared means that the root and the squares cancel each other out, leaving us with the square root of 10 over 2. Now, before you start thinking, oh, great, this can become 5. Nope. The square root of 10 is a square root. The whole thing lives within this square root. 2 is no longer a square root, so these guys have nothing in common with each other now, and you can't just simply divide. What I do have is I have a fraction where I don't have a square root in the denominator anymore, which means it's a legal problem. Okay? And there you have it. Dividing square roots. Fun.